Hello everybody, this is paper 1 from May 2023. This is time zone 2. Question 11 right here, 7 marks. Consider the function f of x is equal to 3x squared minus 5 over x, where x cannot be equal to 0. The graph of f for x is greater than 0 and less than or equal to 5 is shown on the following axes. Okay, so here's our graph. Sketch the graph of f for x is greater than or equal to negative 5 and less than 0 on the same axis. So for this function up here, they've given us part of this graph, but there's some part in this section where x is greater than or equal to negative 5 that we haven't yet graphed, and that's what they're asking you to do. So let's go ahead and work this out. This one is going to require, I think, a little familiarity with the graphing window. So let's graph this function up here, and let's put it into the calculator, and we should be able to complete this section. So let's get a new window, new document, and let's get a graph. So here's our function, 3x squared minus, and let's get a fraction, minus 5 over x. Okay, 3x squared minus 5 over x. Okay, and just returning to the document for a sec, we see we have a window where an x value has a max of 5 and a min of negative 5, and a y value of negative 60 and a max of 80. So if we want to transpose this graph or create like a mirror replica, kind of like carbon copy of this, let's get the windows the same, and it's going to help simplify things. So let's go menu, window zoom, and let's get some custom window settings. So x min was negative 5, x max was positive 5. The scale, I mean, we can put it as 1. That's going to help simplify things because it is on the graph itself a scale of 1. Y min was negative 60. Y max was equal to 80, and the scale in this case was 20. That is to say, it goes up by 20s. Alright, and that's going to simplify things pretty nicely, I think. Okay, so there we go. It would be helpful to find some points, so let's actually just do that. Let's find out what it goes through at, let's say, negative 4. So when we're at negative 4, we're at around 50. So I'm going to plot that in. Negative 4, we're at about 50. And then I'm just going to do the same here. Actually, I'm just going to sweep down. Let's go trace. Let's graph trace. Let's see where we're at when we're at negative 2, roughly 15. Negative 2 is roughly here. And then it might not be a bad idea to find the minimum. So when we're about at negative 1, we're at about 8. Okay. So that looks okay, and I'm going to try to sweep this out as best I can. So here we are, and something like that. Okay, not terrible. I mean, on the mark scheme it actually does say that it should be a smooth curve, so not broken lines, but something like this. So not broken lines, and then of course with this vertical asymptote of x is equal to 0. So where do we approach infinity? As we go up to positive infinity or down to negative infinity, this vertical asymptote, remember, happens when x is equal to 0. Okay. Sketch the graph of f on negative 5 to 0. Good. Write down the x coordinate of the local minimum. That would be this point right here. And actually, going back to the calculator, we had found it already, and that was through menu, analyze graph, minimum, and there it was, once again, 0.941. So write down the x-coordinate of the local minimum. Going back to the document. X is equal to negative 0.941. Okay. Use your graphic display calculator to find the solutions to the equation f of x is equal to 20. Okay, so we had this original function f of x is equal to 3x squared minus 5 over x. That was this function right here. And what they're saying is to find the solution for when f of x is equal to 20. And remember, equals is essentially is when f of x is 20. And so this is f of x. This is f of x, literally. But this is also f of x. 3x squared minus 5 over x. It's kind of the name that we called our function. So when is this function equal to 20? What we can do is we can substitute. Essentially, this is a question what we're asking. What are the x values here that we could put in to this equation, essentially, to get a value of 20? I think it's going to be easiest actually to graphically solve this rather than nsolve. Nsolve is good if there's one solution, but if there's two or more solutions, often it's a good idea to graph. So let's go ahead and solve this graphically. So menu, graph entry, let's create a function and let's write it as equal to 20. Alright, so what are the solutions? That is to say, what are the intersection points? So let's find it. So first one is going to be negative 2.45. So the next one, analyze graph intersection, there's another one here, negative 0.252, and one more intersection point over here, which is equal to 2.7. Okay. Okay. So let's go back to the document and write in these values. So when x is equal to negative 2.45 and x is equal to negative 0.941, and when x is equal to 2.7. There we have our three solutions, our three intersection points. Write down the equation of the vertical asymptote for the graph. So C, remember vertical asymptote. Asymptote essentially is a line that we approach but never reach. So vertical asymptote in this case, or in all cases really, is a line that you approach but never reach. And this would be your vertical asymptote in this case, the line where x is equal to 0. Here it is, this line that we approach but never reach, the line that we come close to. Remember, horizontal asymptotes in this case would be on the horizontal axis. What do we approach but never reach? Well, in this case it would be y is equal to 0. So vertical asymptote occurs when x is equal to 0. And lastly, they're asking us to write this as an equation. So please do not forget the equal sign. X is equal to 0 for for vertical lines. Let me just show one other example really quick. If we had some equation which was shifted over just slightly, so let's say it looked like this, and then like this, and the vertical asymptote was, let me change this just slightly, and the vertical asymptote was right here, so this line that we approach but never reach, this would be x is, let's say, equal to 2 if this point right here was 2, for example, and so on. So vertical lines have this equation x is equal to 2, and if we're considering horizontal asymptotes, So let's say there's a parachute jumper, and they jump out of this plane, and this is their velocity, and initially it's 0, and then they reach some kind of terminal velocity, but they never actually reach this value. This would be our horizontal asymptote, and it would be y is equal to, let's say, I don't know, 20 meters per second or so, something like that. So this is horizontal, has this y value. Y is equal to 20.